Hello and welcome to MakeLearn 360. So in this video, I want to teach you or explain to you how to resolve forces which are concurrent and coplanar, several of them. So several concurrent coplanar force system. So what do we do? Consider each force and resolve into x and y component. Now to simplify the problem, a table is drawn showing the individual forces and their respective components along the x and the y directions. Now we will have to choose a convention to assign the magnitude and the direction of the forces. So every force to this direction is positive in the x. Similarly, every force in this direction will be positive in the y. Alright, so these are the forces F1, F2 with a triangle, F3 with beta, F4 with alpha, and then F5 just as it is right here. How can I find the resultant of this force system? Okay, so I've done everything here which I want to explain, but for now, can you pause the video and try to resolve all these forces to see whether you get the same results as what is here? Okay. So this is F1 right here. It has only a component along the x, and so the angle it makes with this is 0. So F1 cos 0 becomes F1 itself, and then F1 in the y direction is actually 0 because sin 0 becomes 0. Now I have F2. I was not given the angle, so that's why I wrote null here. There is no angle. However, I have a false triangle, so I will be able to reduce this into x and y component. First of all, draw a rectangle. Then I have F2x along the x direction, F2y along the y direction. To get the x component is going to be the horizontal side of the small triangle divided by the hypotenuse of the small triangle. Then you multiply by the F2 to get the x component. Similarly, to get the y component is going to be the vertical side of the small triangle divided by the hypotenuse of the small triangle, then you multiply it by F2. That is what we have here. Similarly, for F3, draw a rectangle like we have been doing, x component, y component. Now looking at F3 here, the x component is towards this direction, and so it is F3x. And then for the y component, it is in this direction. But look at this. This is positive. However, this is negative. You know, we said every force this way is positive and every force this way is positive. And this is the reason why we are getting this result here. Now looking at F4, drawing a rectangle and getting F4x, F4y, clearly you can see that this alpha here is opposite to the side. And so F4s now becomes sine. So don't really memorize that all the time x will be cos and then y will be sine. No. Look at the geometry. And so this is F4x and then F4y. So F4x becomes minus because it is in this direction. Similarly, F4y also becomes minus. Right? They are opposite to the direction we chose. Now, let's look at F5. F5 is just on the axis. And so for F5, it is just right there. But look at it, cos 0 becomes 0, and then sine 90 is actually 1. Sorry, cos 90 is 0, and then sine 90 is 1. Now looking at this carefully, you can clearly see that the y here is opposite to the y you chose, and so this is negative. That's the reason why we are getting this. So what we have done is that we've been able to reduce this. So the resultant squared is going to be this, and this is the angle. But what are we saying? So what we have done is that we've been able to reduce all the forces into some force Fx. And this Fx is actually the summation of everything here. And then this Fy right here is the summation of everything here. Now the assumption is that we are assuming that this Fx is positive and this Fy is positive. However, in your question, you would have to know the quadrant which it will fall, depending on the value of Fx you get and then Fy that you get. And so this is how to resolve a force which is concurrent and coplanar. I mean, several of them. Thank you for watching.